Okay, here's some solutions to some specimen papers. It is the paper June 2015 specimen, higher level GCSE maths. And we start at question 1. Circle the calculation that increases 400 by 7%. Well, a couple of things you should know is that 7% is 7%, 7 over 100. So what we're actually doing, although you don't need to know this necessarily, you could just remember that you multiply by 1.07. But let me say why. Well, basically we start off with 400, and we're going to add to that 7% of 400. 7% of 400. Okay, so that's what we're doing. Now you can see that 400 is a common factor to both of these. So we'll take out 400 as a common factor, and left with, well, what do I get 400 from 400? Just 1. And then plus, and then here I get 7 over 100 times 400. So the 400 is already there, so I just get 7 over 100. So this, of course, is 400 times, and then 1 plus 7 over 100. Well, 1 is the same as 100 hundredths. That's 100 hundredths. So in total, there are 107 hundredths. Yeah. And of course, 107 hundredths is 1.07. So this is 400 times 1.07. Again, you don't need to know all that, but it might be nice to see where it comes from so you can understand why it's 1.07. Simplify the answer. 3 to the 4 times 3 to the 4. Well, here we're after the laws of indices that says a to the b times a to the c is a to the b plus c. So we've got the same base, potentially different powers, but not in this case. We need to add them up. So we've got 3 to the 4 plus 4, which is 3 to the 8. Circle the area that is same as 5.5 meters squared. And we've got to change things by the looks of it. Look at the answers into centimeters squared. These are all centimeters squared. Now I find the best way to change things from one unit to another is to do this. We're at 5.5 meters squared. Now what we want to do is we want to change this meters into centimeters. So I'm going to write exactly the same things here, 5.5, but instead of meters, I'm going to write centimeters. I can't do that because a meter isn't the same as a centimeter, but a meter is the same as 100 centimeters. Okay, so that's the equivalent of this box. I'll put brackets around it, but you could just think of those two red boxes as being the same thing, which we agreed at 100 centimeters, which is this larger box, is the same as a meter. Now if we do that, we must remember that when we've got two things multiplied together and we square them, we must square each one. A little bit like saying a times b all squared. That's the same as a squared times b squared. So we're doing that trick here. So this is centimeters squared times 100 squared. Now 100 squared is 100 times 100. So this is 100 times 100, add 2 noughts, times 5.5, and then centimeters squared. So we need to multiply by 1, 2, 3, 4 noughts. So we move the decimal place 4 times. From there to 1, 2, 3, 4 to there. So the answer is 55000 centimeters squared. Question 4. Which of the graphs shows the sketch of y equals 1 minus 2x? Right, now the first thing to remember here is we're talking about y equals mx plus c. So this here is equivalent to y equals minus 2x plus 1. Now remember what these things stand for. This is the y-intercept, and this m here is the gradient. And also remember that we have a negative gradient here. So a negative gradient, the line must be going in this direction here. Not this direction, this is a positive gradient. This one is a negative gradient. So it must be going in this direction. So the possibilities now are only left with two. That this is a positive gradient, so this is wrong. This is a positive gradient, so this is wrong. So it must be one of these two here. And remember that the y-intercept here is this number here in the red box. So that's +1. So the only one that has a y-intercept of +1 is this one. So this is the correct one. Question 5. Scattergraph shows the age and price of 18 cars. The cars are all the same make and model. Use a line of best fit to estimate the price of a 6-year-old car. So a line of best fit is a straight line, so we're going to draw a straight line. And we want to make the straight line so that it averages out all of these dots. So we want to make sure we get as many crosses on the line as possible. And if we can't do that, which of course we can't, then we want to get as many on one side as we do on the other. So it's going to look something like that. And there will be a bit of leeway for this question, but that gives you an idea of what the best line of fit would be. And then it says use a line of best fit to estimate the price of a 6-year-old car. So we want a 6-year-old car, so that's going to be an age 6 car. We're going to go up to the line and then across. Then there's going to be some sort of a approximation going on here with the line that we've drawn. And we get this price here. So we're looking at this value right here. So that's 3,000. Each one of these is going to be 200, 3,200, 400, 600, around about 3,700 pounds. Question 6. Kelly is trying to work out the two values of W for which 3W minus W cubed is 2. Her values are 1 and -1. Are her values correct? Okay, well, let's try them. So let's try if W equals 1. So here, if W equals 1. So we're going to have the left-hand side of this. So that's what I mean by the left-hand side is this bit. This is 3 times W is 3 minus W cubed. Well, that's going to be 1 cubed. 3 minus 1 cubed is 2, so that's okay. If W is -1, then so this is the right-hand side, by the way, so that's the right-hand side being 2. Here. If W is -1, then the left-hand side becomes 3 times -1 minus -1 cubed. Notice that we're being very careful here that W is being cubed, so all of -1 is being cubed. So here we're cubing 1, here we're cubing -1. So let's be careful with our negatives here. 3 times -1 is -3, minus, and then -1 cubed is -1. So we've got -3 minus -1, and these two minuses multiplied together gives a positive, so that's -3 plus 1, and -3 plus 1 is -2. This is not equal to the right-hand side. So W equals -1 is incorrect. Now notice what I'm doing here is, the question is, are her values correct? I must conclude properly with these questions. Okay, so it may be that the mark scheme would allow the fact by just trying W equals -1 and stating that not equal to the right-hand side is fine, but just in case, make sure you conclude properly by answering the questions. Are her values correct? So no, all her answers are not correct, so we must conclude there. Okay, so now what we're doing is we're multiplying these mixed fractions. So the first thing we need to do is must convert these into improper fractions. So 2 and 3/4, 2 fours are 8, plus the 3 is 11. That's 11 quarters times. Now 1/7 is 7. 7 plus 5 is 12, so that's 12 sevenths. So that's what we're multiplying. And now, of course, we can cancel down a bit. So we're going to cancel 4 goes into 12 3 times. So we're going to get 11 times 3. Remember, multiplying fractions, cancel down first, multiply the numerators, and multiply the denominators. Now, it says give your answer as a mixed number, so we must do that. So how many 7s go into 33? Well, that's 4, because 7 4s are 28. And that leaves 5 remaining, so it must be 5 sevenths. So it's 4 and 5 sevenths is our answer. Inequalities now. Remember, inequalities, you basically solve as if this was an equal sign, except, solve like equals, except, you must remember, if you multiply or divide by any negative value, switch over the inequality sign. Switch over the inequality sign. Okay, that's the key thing that you must remember for inequalities. So let's try and solve that. So we're going to treat it like an equal sign. So if it was an equal sign, we would subtract 3x from both sides to get all the x's together. So if we subtract 3x from 5x minus 2, we're of course going to get 2x. And we are going to add 2 to both sides, so it's greater than 13. And notice we have not divided or multiplied by any negative value. In fact, we added things to both sides, so that's fine. Okay, adding a negative to both sides, fine. But multiplying or dividing is not, unless you switch over the inequality sign. So now we simply divide both sides by 2. Again, we're not dividing by a negative number, so we're okay. So x is greater than 13 over 2.